All right, algebra students, lesson 9-2, video 2. We have 2 problems to do. So it says, how can you use factoring to graph the function? Okay, so let's begin by factoring this, finding those answers, and then we'll go from there in terms of graphing this quadratic. So this is our quadratic function, right? Remember that the solutions to this quadratic equation will be the same as the zeros of the quadratic function, which will be the x-intercepts on our graph. And this is the key, right? We're going to find x-intercepts. So if there's 2 solutions, we have 2 x-intercepts. And we can use that to then find our vertex and go from there to plot our parabola. Okay, so let's first set up the related equation, if you will, by setting that equal to 0. Okay, so now we're going to look for a GCF. I'll do it over here this time to save myself some space. No coefficient, no variable, so there is none. Okay, so now we're going to create our x here. Okay, I have a -8 on top. That means your signs are different. One's plus, one's minus. A -2 down here. Again, that's going to be the bigger number. So we're looking for the factors of -8. That sum to -2. Remember, since the signs are different, really, they're going to subtract to -2. And I think the numbers are 2 and 4, right? 2 times 4 is 8. If we make the bigger number negative, +2 plus -4, that's going to be -2. There you go. So your numbers are +2 and -4. +2 and -4. So x plus 2, x minus 4 equals 0. Set each factor equal to 0, because at least one of them has to be 0. Subtract 2 on both sides, x equals -2. I'm getting ahead of myself. Add 4 on both sides, x equals 4. So here's your 2 solutions, which means that you have 2 x-intercepts. One's at -2, 0, and one's at 4, 0. So I'll go and graph that. -2, 0, and 4, 0. Now, the most important point of any parabola is the vertex. But what's nice about the idea of parabolas and symmetry is that because you have your 2 x-intercepts, your vertex will be right in the middle. Your axis of symmetry will be right in the middle. So if you can take the average of these 2 numbers, so to take an average, you're going to add -2 plus 4 and divide by 2. That's 2 divided by 2, that's 1. This is going to be the x value of your axis of symmetry, or the equation, and your vertex. So this is your axis of symmetry, and it's also the x of the vertex. So your vertex also has an x value of 1. So we know that your vertex will be somewhere on this dotted line. And again, that's all because of symmetry. We know that these 2 x-intercepts are an equal distance away from this axis of symmetry. And now to find the y, again, how many times I have to tell you? You have a function, you have an x value, plug it in, right? Y equals 1 squared minus 2 times 1 minus 8. And again, you just plug this into Desmos to get that y value. That is going to be -9. So your vertex is at 1, -9. I will do that in purple. 1 down 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, do your best as I will try to, look at this, to graph the parabola going from the vertex up through each x-intercept. And that's how you can use graphing, or not graphing, factoring to graph a quadratic. Okay, and last but not least, right, let's take a look at number 5. It says, how can you write the factored form of the quadratic function related to its graph? Okay, so we have a graph here. Factored form for a quadratic looks like this. I don't know what I just did there. That's I made up that letter. That's in between a G and something. F of x equals a, and then it's x minus p times x minus q. Now, the x's may have some coefficients too. It just depends on your p's and q's. But for our purposes, this is what it is, right? Understand that in this problem, right, your a value is what controls the width and direction. Your p and q are going to be your two factored values that make that c value, but you're going to get them from the x-intercepts. Okay? And then your x and y are an x and y, right? Now you say, where's y? Remember, f of x is y, right? So we really have y, x and y, p and q, and then a. Okay, so from this graph, they give you the two x-intercepts. So one x-intercept is -5. Let's let p equal -5. The other x-intercept is 1. Let's let q be 1. So that means when you plug them in, it's going to say x minus -5 and x minus 1. Okay? Now I know that this minus will turn plus, so this will be x plus 5 and x minus 1. Okay, we're there. Next, so I'm gonna skip this. I'm gonna write down here. I'm gonna put y, right? Y equals, not f of x equals. So y equals. Now, the last point you know is the vertex. This vertex is at -2, -9. You can use this as an xy pair because it's on the parabola. So let's plug in -9 for y. We still don't know a, and let's plug in -2 for x both times. So it's the same thing both times, -2, -2. And now we're going to type this into Desmos all at once, not the a, just -2 plus 5 in parentheses times -2 minus 1 in parentheses. This is going to give you -9. This will be the coefficient of your a. -9 equals, again, it just so happened it was also -9, equals -9a. To get a by itself, divide by -9, and your a value is a 1. So now the factored form, the final answer of this will be f of x equals, you don't need the 1, so I'm not going to put this one here, but you could, right? But you don't need it. Don't need it. Not needed. And then it's going to be x plus 5 and x minus 1. And there's your factored form. Again, if you try to input this in Savas and they don't like the 1 there, that could be why. And you could multiply that out to get your standard form and we'd be in business. Okay? All right, there we go. Okay, so thanks for watching this video. Good luck on the 8-2 or 9-2, and we'll see you in class.